So let's look at how to graph sine and cosine. So similar to our Ferris wheel setup, we're going to be kind of looking at the circle, which is going to be our unit circle. And then how do we translate that into coordinates, kind of inputs and outputs. Now the inputs for our function, and that's specifically the inputs for our sine of x. So remember, our inputs are the angle measurements. We plug in an angle measurement to sine, and it gives us a y-coordinate from our unit circle. And with that, our input, so what we're going to be mapping along the x-axis here, are going to be angle measurements. Now this can be in radians or degrees. Typically we'll be working in radians. So you'll be seeing that a lot, but we could just translate these to degrees and it would be the same shape. Now, grabbing the outputs for our sine of x function, what I want to do is go around our unit circle and grab our sine values, which come through as the y-coordinates on here. Now, I'm saying y-coordinates here, and something we need to be careful of is that while these all connect, the coordinates here are different from the coordinates down here. So in this case, it kind of lines up because sine of x is y. But I'll bring this up again when we look at cosine because it's going to be the same exact setup. So when I say y-coordinates here, it doesn't necessarily always mean y-coordinates here. So we just want to be careful of that. So instead of y-coordinates, let's say the sine values. It's just that we look in that location to grab those sine values. Now, I could have made this with those pi over 6 values and pi over 3 values, but we're going to simplify it a little bit and just look at our increments of pi over 4. So when I'm at 0, so when I plug in 0 radians into my function, the output is 0. So we're going to have the coordinate 0, 0. When we're at pi over 4, the output for my function is root 2 over 2. And at pi over 2, we're at 1. And at 3 pi over 4, we're at positive root 2 over 2. At pi, we're back to 0. At 5 pi over 4, we're at negative root 2 over 2. At 3 pi over 2, we're at negative 1. 7 pi over 4, negative root 2 over 2. And when we get back to 2 pi, we're at 0. And then that's where our graph is going to start repeating itself. Now, graphing root 2 over 2 is kind of tricky, so I just need a decimal estimate to help me out, and that should be about 0.7. Alright, so I want to graph this function here. Now, looking at my x-coordinates, I definitely want to see at least one period of the graph when I make this graph. So with that, I definitely want to see between 0 and 2 pi, and then going beyond that is even better to get more information. But if we see between 0 and 2 pi, that's going to contain kind of the full relationship that we're looking for. And then what I can see from the outputs of the function, or what I'm calling y here, so these outputs I can see are going to go from 0, they can go as high as positive 1, and then go as low as negative 1, which makes sense in terms of the restrictions of our unit circle, that those y values are stuck between negative 1 and positive 1. So let's start making this graph. So we have the point 0, 0. We have the point, let me use a different color here just to make it brighter. At pi over 4, we're at about 0.7. So let's see if that's halfway. Let's see about here. 0.7. When we're at pi over 2, we're at positive 1. At 3 pi over 4, we're at 0.7. At pi, we're at 0. 5 pi over 4, we're at negative 0.7. At 3 pi over 2, we're at negative 1. 7 pi over 4, 2 pi. And if I connect those dots, then we can see our periodic function coming through. And it will continue on and repeat that behavior in both directions. To negative values, because we can plug in negative angle measurements, that's completely fine. It'll just repeat this behavior between -1 and +1 over and over again. So this right here is our graph of sine. And what we're going to do is get our graph of cosine as well, and we'll want to memorize kind of the general shape of these. And what I think of to remember sine, it's typically listed first. We kind of think of sine first and then cosine. It's just how it's set up. And with that, I just think of sine as starting at the origin, and then we always start by going upward, not downward. I kind of think of like a roller coaster. We're starting at the exciting bit. We're starting at the point where we're heading up to that peak before we dip down. So that's the start of our sine function. For the period of the function, we can see if we're starting here at 0, 0, we see this behavior of our graph, and it starts repeating at 2 pi, so that horizontal distance of one period of our graph is 2 pi. The amplitude of our graph is going to be this distance right here, this vertical distance between the midline and the peak. So that's going to be 1, which again relates to the radius of our circle, which we know from the unit circle, our radius is 1. The midline comes through as this middle piece of our graph here, and that midline is going to be y equals, and the line will be at 0. So a horizontal line through 0. So those are kind of the 3 important pieces of our graph. Domain and range. So in terms of input for our graph, we can plug in absolutely anything. Negative, positive, 0, we can have any angle measurement and plug that into our graph. And as we can see from our graph, it's continuing on to positive infinity, continuing on to negative infinity. There aren't any asymptotes, there aren't any holes in the graph. So for domain, we're going from negative infinity to positive infinity. Now for the range of our graph, we're restricted. So if I'm coming from negative infinity, I'm not going to see any sine output values below -1. So our graph starts at -1 and includes -1. And then we can see we have function values all the way up to and including +1. So our range is stuck between -1 and +1, including those endpoints. So we use those square brackets. Now with sine, because something we're going to do is we're going to get into graph transformations. I kind of want to show you how to think of dividing up our graph, because there's these kind of special points that are occurring here. So with sine, there's going to be this kind of beginning and end point. We have this starting point, and then the period can help us find out where the ending point is, even though our function isn't actually ending, but in terms of graphing within a single period. So for sine, that's going to occur on the midline, or in this case, the x-axis. We're going to talk about moving around the midline though. What you could see is that our beginning and end point are both crossing through the midline. And then there's this really nice symmetry that occurs. Because halfway between those two values, we're crossing the midline halfway between. And with that, halfway between those two values, we have our maximum and our minimum. So I'm going to bring this up again, but I just kind of want to point it out as we're starting to think. There are these 5 special points. And the idea is that if I know I have a sine graph, and I know where I'm starting, and I know the period for getting to the end, I can pretty much map the rest of it. I know halfway between those would be a max, halfway between those would be a minimum, and I'd have my sine graph started. Oh, I missed that last point, but close enough. I'll move it right there. So that's going to be something that we use in our graph transformations, is general shape of sine. If we start making transformations to sine, what I'm going to be bringing up are these kind of 5 special points that we're working with. And so that you have the beginning and end of your graph based on the period. You can find the others just with symmetry and thinking in terms of halves. Alright, let's go to our graph of cosine, which will be a very similar process. The difference will be that when we're looking at our graph here, cosine is coming through as the x-coordinates. And this is the point that I wanted to make, is that because they're x-coordinates here, that doesn't relate to the x-coordinates on this graph that we're making below. Our input for our cosine function is still degree measurements, or radians. They're angle measurements. There we go. So we're still inputting angle measurements, and then for our y values to make our graph, they're just coming from the cosine values. So really we just need to find our cosine values, which show up in this location on our unit circle, which is x-coordinates, but that's where I kind of want to make this disconnect of x and y. The x and y here is behaving differently from x and y there. So, it's a bit confusing, but just trust me. So, we want to grab these cosine values along the outside. So, when we're at an angle measurement of 0 radians, cosine is 1. When we're at pi over 4, cosine is root 2 over 2. When we're at pi over 2, cosine is 0. At 3 pi over 4, we're at negative root 2 over 2. At pi, we're at negative 1. 5 pi over 4, negative root 2 over 2. 3 pi over 2, we're at 0. Root 2 over 2, 1. So just going along the outside of that unit circle, grabbing our cosine values. So as you can see, we're having the same output values as sine. It's just occurring in different places. So when we make this graph of cosine, it's going to look very similar. If not, like, in terms of the cutout, it's the same exact shape. Same slope, same rates of change, same output values. They just occur in different spots. So, a graph of cosine is starting at 0, 1. So we're starting up at a maximum value here. And then, let's see, about 0.7, 0, negative 0.7, negative 1, negative 0.7, 0, 0.7, 1. So, our graph, and so I just need to slow down to make the graph here. Accurate as I can. Alright, and then it continues on forever in either direction, but here we can see a single period. So in terms of shape, sine and cosine connect. It's like if I continue the graph here, right here is our piece that is cosine. So, same graph, just shifted basically horizontally. We'll make that connection later, how you can relate these graphs through horizontal transformations. Like if we just bump that over there, it becomes cosine. So, period of the graph, 2 pi, which makes sense as we're going around the circle grabbing these values. To go around the full circle, we would have an angle measurement of 2 pi. Amplitude, or the radius of that circle, is 1, and the midline is still y equals 0. So, same characteristics coming through in terms of period, amplitude, midline. Domain and range, also the same. We can input absolutely any value for our angle measurement, and we can have an output. For the range, we're restricted between negative 1 and positive 1 inclusively, so we can include negative 1 and go up to positive 1. Now, those kind of 5 special points that I was pointing out with sine occur here as well. It's just the beginning and end of our graph are at a different location. Now they're occurring at the peaks of the graph. So we'll have those 2 peaks. Halfway in between those peaks is the minimum value. And then halfway between those is where we cross the x-axis. So with cosine, when I visualize these, if I have my starting point, and I use the period to find the ending point, and we'll have our midline and amplitude to work with as well, so we'll have an idea of where these maximum and minimum values can occur. Halfway between those would be the minimum value, and then halfway between those would be on the midline. And then with that, we can connect the graph to do that. So we'll keep in mind those 5 special points. With memorizing cosine and sine, and just getting used to like which one starts at the origin and which one starts at the peak. So cosine starts at the peak. If it helps really to know where cosine and sine start, you just need to remember that first measurement there of when your angle is 0, you have the coordinate 1, 0. And when you're with cosine, the output is positive 1. When you're at sine, the output is 0. And then from there, you complete the rest of the graph.